Hello everyone, this is Dr. N. Srinivas, Associate Professor in the Department of ECE, Lecture1 Institute of Technology and Management, Autonomous Institution. Today I am here to discuss a course on signals and systems and presentation outline. We discuss course objectives, course outcomes, course syllabus, and detailed syllabus in terms of units, unit wise is there. So unit 1 represents signal analysis, unit 2 Fourier series and Fourier transforms, unit 3 signal transmission through linear systems, unit 4 Laplace transforms and jet transforms, unit 5 sampling theorem and correlation. These are the headlines of each and every unit in the syllabus. Course objective. Why should we study this course first? This course is basic fundamentals for any subjects in BTech engineering, because this is a signals and systems. If you understand the basics, then you can understand all other subjects. If you take other subjects, communications, control systems, electronic device and circuits, analog circuits, microwave engineering, cellular communications, okay, all these things subjects, this course is very basic for all. So in this course, what student can expect? What are the objectives of this course? The student can learn the basics of signals first and systems. It is required for all engineering related courses. The student can understand the behavior of the signal in time and frequency domain. So we have some transforming techniques like Fourier series, Fourier transforms, and the student can understand the characteristics of linear time invariant systems. And here particularly we study convolution operator. And the student can easily analyze the concepts of signals and systems and its analysis using different transform techniques. And also, finally, student can get knowledge on probability. They can understand what is random variable, random signals. So finally, they can easily estimate the correlation and CDF and PDF. And the course outcomes. After successful completion of this course, the students will able to express mathematical description and representation of continuous and discrete time signals and systems. They can easily relate any arbitrary signal in time domain, frequency domain, and resolve signals in frequency domain using Fourier series and Fourier transforms. They can easily identify input-output relationship for linear time invariant system. Also, they can easily apply convolution operation on both the continuous and discrete time systems. They can easily appraise signals with the different transform techniques by using Laplace and jet transforms. They develop a system for sampling and using some concepts, probability, random variables and random signals. Finally, they can assess autocorrelation function. They can evaluate energy and power density functions. And this is the syllabus of signals and systems as per JNTU University. This is our affiliated university. So the detailed syllabus is given here. Unit 1 represents signal analysis. So particularly we discuss analogy between vectors and signals. What is meant by signal? What is the signal space? What is orthogonal function? Mean square error? So what are the complex functions and what are the classification of the functions, operations on the signals? Okay, so different types of elementary signals will be studied in unit 1. Finally, say unit 2, in unit 2, Fourier series and Fourier transforms will be studied here. And there are some limitations on Fourier transforms. So that's why we move to some other transform techniques that will come in the next slide. So unit 3 represents signal transmission through linear systems. So what are the types of systems? Time invariant, linear time invariant, non-linear systems, okay, causal system, non-causal system, and so other many other types of systems will be studied here. And relation between bandwidth and rise time, so convolution and correlation of the signals, and some other graphical representation of convolution will be studied here. And unit 4 that I have already given note on Fourier transform, that the Fourier transform is having some limitations. That is why we are moving to Laplace transforms and Z transforms. And we study all the types of transforming techniques in unit 4. And unit 5 deals with sampling theorem and correlations. And here we study different types of sampling theorems and how to reconstruct a signal after sampling, that will be studied here. And the correlation, how to find the properties of correlation function, how to calculate energy density, okay, how to calculate power spectral density, and what is meant by autocorrelation function, how to detect a periodic signal in presence of noise. So these things will be studied in unit 5. And we have enough textbooks for this course. Signals, Systems and Communications by B.P. Lathi. That was the important textbook for this course. Signals and Systems by A.V. Oppenheim. Okay, that is the second textbook. Also, some other reference textbooks also mentioned here. Right. So this course is, I've already told that very important for your semester academic exams, and it is also very important for GATE exams. It is also important for IES exams and also for any government sectors. Okay, so this course is very important. So now we discuss signal analysis of unit 1. So in the unit 1 we have many topics like analogy between vectors and signals, orthogonal signal space, signal approximation using orthogonal functions, mean square error, closed or complete set of orthogonal functions, orthogonality in complex functions, classification of signals and systems, operations on signals, exponential and sinusoidal signals, concepts of impulse function, unit step function, and signum functions. All the topics will be covered in signal analysis, that is unit 1. Now we discuss introduction about signal. So what do you mean by signal? How we can define a signal? A signal is a function of one or more independent variables that carries some information to represent a physical phenomena. In general, we can discuss like this signal is a variable. It varies with respect to time, that carries some information. It consists of one or more independent variables. So we can say some variables like amplitude, frequency, and phase. These are the variables of a signal. So signal carries some information, and in terms of amplitude or phase or frequency. And example for this signals is ECG, electrocardiogram. It gives that signal gives information about heart. Okay, so these signals will be studied in medical applications. And there are two types of signals: continuous time signal, discrete time signal. How do you define a continuous time signal? If you see the graph in this slide, x of t indicates continuous time signal notation, that is a function of time. So it varies with respect to time t. Means if you take any time instant, the signal has some value. For all the points, signal having some values. That's why the signal is called continuous time signal. It is continuously varying. It is continuously varying, right? So the best example for continuous time signal is human speech, and also it is displayed graphically as a line. So this is a continuous time signal. Now if you see discrete time signal, so directly we have seeing the waveform. So what is your observation from this graph? So x of n, it is the notation for discrete time signal, and it varies with respect to n, where n indicates discrete time intervals. So n is equal to 1, 2, 3, 4, 5, 7, 8, 9, 10 up to infinity. Means for every discrete time there is a value. Means for a specific point of time the signal has a value. That's why this signal is a discrete time signal. Now the point is how to get discrete time signal from continuous time signal. We are using sampling process we are applying. So the sampling process will be discussed in the next slide. presently. So discrete time signal example is MP3. So the music signal which is saved in the format MP3, that is also a discrete time signal. Now we are seeing two types of signals: continuous time signal in the left side, in the right side discrete time signal. So this you can see the difference, right? So continuous time means what? So the signal consists of amplitudes for all time instants, but in case of discrete time, for a specific points of time, the signal is having some values. So this is the difference between continuous time and a discrete time signal. Now we are seeing sampling. So what is the sampling? What is the importance of sampling? So sampling converts a continuous signal x of t to discrete time signal x of n. So what is the role of this sampler? What is going inside the sampler? So there is a switch, on off switch. It closes at time interval t and it opens after time interval t. So this is a operation on and off operation of switch inside the sampler. For every t seconds, one sample is coming out from the sampler. Means continuous time signal is converting into discrete time, and for every time t seconds we are getting one sample from the sampler. So this is the conversion of continuous time signal to discrete time signal. And thank you all for listening, for your patience. And if you have any doubt, you can contact, this is my mail ID. And thank you all once again. We will see the next lecture, okay, after in the upcoming lectures, right? So thank you.